Hello, everyone. We are close to a minute off from getting started. Let's just let more people join, but welcome to the session on containers for better science. We'll have 3 presentations today. Each will be close to 15 minutes long. So we'll have maybe 12 minutes of presentations and then a couple of minutes for questions. We do have a 15-minute session at the end just for general discussion. So that's going to be sort of a mini panel, and then you can ask additional questions then as well. During the talks, please use the Zoom chat for any questions that you want to be addressed right away. If you have more open-ended questions, you can use the Google Doc that's there in the Kiko chat interface, and we can go over them towards the end. So with that, our first talk today is on a serverless gateway for the execution of open machine learning models in AWS. I believe this is pre-recorded, and our presenter will be Diana Maria Rania Delgado. So Abe, if you would play the recording.
Hello everyone. First of all, thank you very much for attending this presentation. My name is Diana Maria Naranjo Delgado. I'm a PhD student in the Grid and High Performance Computing Group at the Universidad Politécnica de Valencia in Spain. My presentation today is about a serverless gateway for the execution of open machine learning models on AWS. The content of the presentation is based on 6 fundamental points: introduction, objective, architecture, use case, demonstration, and conclusions. Deploying machine learning models or artificial intelligence applications on on-premises servers face certain complexities, and servers require regular maintenance and cannot easily be scaled up on demand without downtime. In this sense, serverless computing emerged as a scalable and cost-effective solution to address the main resource provisioning challenge faced by machine learning users. Serverless computing is a completely self-management service in which the cloud provider manages the underlying infrastructure, so developers only need to focus on the functionality of their application. Therefore, the objective of the work is to design a server-based architecture that integrates models from existing catalogs of machine learning models already trained and publicly available with a serverless cloud computing platform. The platform has 3 fundamental components. The BAS API is a REST API written in Python that provides easy access to machine learning, deep learning, and artificial intelligence models. For our case study, it was necessary to develop a command line tool that would allow obtaining the prediction of the model, so we implemented the DBAS predict command. SCAR is the other component of this architecture. It's a framework for executing containers from Docker images in AWS Lambda to run event-driven applications. SCAR has 3 execution modes through which the prediction can be obtained, using AWS Lambda or AWS Bash. The last of the component is a user interface that represents the front end of the web-based architecture, allow users to obtain the prediction of machine learning models in a user-friendly way. Okay, the image shows the architecture of the platform where previously the administrator, through the SCAR client, create the function with the model to be integrated. Users can authenticate in the web through method, using their cognito credentials if they are deep users of the deep EM provider. Once the user has authenticated with the temporary credentials obtained from AWS, it is possible to interact with the files in the S3 bucket. Once one of the models is selected, when a file is loaded to the bucket, it requires that the function to be activated and the file to be processed in AWS Lambda or AWS Bash as specified in the creation of the function. The resource is stored in the output S3 bucket. The case study is made up of 4 publicly available models. There are 3 models from the deep catalog, an ADO classifier, a plant classification, and a body post detection models. This model does not meet the space limitations of AWS Lambda. Therefore, they will run on AWS Bash. To implement the Lambda execution mode, we decided to integrate the Darner example to classify objects. Now it's time for a demonstration. On some static time, I have recorded a video to adjust it to the presentation time. I will first comment on the administration part for the example of body post detection model. For the creation of the function through the Scar client, two files are necessary. One is the script to be executed within the function, in this case, dpass.sh, and the other is the definition of the function, where it is necessary to specify the name of the function, the execution mode, in this case, the bash, because the image doesn't meet the limitation of AWS Lambda like I mentioned before. In addition, the storage provider for the input and the output files are defined. In this example, we use Amazon S3, where we define the path for the input and output files. To create the function, the command scar init is used, and the configuration YAML file is specified. After a few minutes, we should obtain that the function has been created successfully, like we can see in this part of the video. Okay, now, on the other hand, in the AWS console, we can see the service created through the Scar client with the command scar in. In Lambda, we have 5 functions related to our platform, one for each model, and the scar the pass list job function to check the status of the jobs that are executed in AWS Bash from the web interface. In the AWS Bash service, we can see the job queues of the 3 models that run in Bash, which are the audio classifier, the plane classifier, and the body post detection model. Finally, in AWS S3, there are 2 buckets that are used, one to store the web interface, in this case, ScarDpass UI, and the other bucket is to store the input and output file for each model. Within this bucket, there is a folder per model, and within each model folder, an input and output folder. Okay, now we'll comment on the user part. So this URL, you can access the web interface where it's possible to authenticate through the Cognito username and password or through the deep EM provider. In this case, we authenticate with the Cognito credentials. In the web interface, there are several sections where it is first necessary to select one of the available models. Once the model is selected, 2 information link appears. One with an example of the input file, in this case, an example of the body post detection model, and the other link is to the repository of the model to obtain more information about the model. The section to get the status of the job is only available for model running on AWS Bash that are long duration. For example, in the Darknet model that is in AWS Lambda, this section is not shown. There is also another section to review the input and output files in the bucket for the selected model. Okay, now we are going to proceed to load a file to see the output for the body post detection models, which is the one we have selected. Once the file is loaded in the input folder, we can see the file that we have just loaded. And in the job state section, we update and see how the job appears in runnable state. In this section, we have added an information link about the meaning of each of the state that a job can throw once it has submitted. Okay, this process might take several minutes and there is no provisional machine yet, so I will continue until I see change. After a few minutes, we see that there is already a provision machine and the job status changes to started. So we are there again, the job start is now running. Okay, the execution time, that is the approximate time from when the files begin to be processed until it is finished, is around 15 seconds. So we're going to do that again, and previously we had 3 jobs in succeed. Now, if we are there again, we can see that we have 4 jobs in succeed state, indicating that the job was processed successfully. In the output folder, we can see the result of the prediction. Also, this process took several minutes. If we have a provision machine and we will load another image, the process is more faster. The job goes directly to the running state After a few seconds, the process is completed. So we are going to date, and now we can see that the job is in running state. So we're there again. Okay, let's do it again. And maybe 50 seconds until we have the result. Now we have the 5 jobs in succeed state. In the output folder, we have the 2 results. From the web interface, it is possible to delete and download the files from the bucket. We are going to download one of the results, and we can see 2 files. Okay. Now we're going to open the folder. Okay, we have the output.json file that give us the result of the prediction in JSON format. And in the image, we can see the points marked by the prediction of the model. Okay, now, as conclusions, we can see that this presentation has introduced a serverless architecture to make it easy for users to invoke machine learning models through a web interface. The architecture uses AWS as execution backend, offering scale to 0 to minimize service operation costs. The proposed solution constitutes a step forward in simplifying the execution of artificial intelligence model by end users. Okay, in this slide, you can see the name and contact information of the author of this work. So if you have any question, you can contact with us. Thank you very much.
Thank you. Well, I think we've got one question here in the chat, but yeah, anyone, if you have any questions, please do put it in the chat or in the Google Doc, and I'll just take them in the order they appear. So the first question is from Lance. He's asking, the files used in this portal must be quite small. Has it been tested with video files or files greater than 4 gigabytes in size?
Hello, I will keep the video off due to the internet connection. So the portal have just tested with files because the implemented models only are available for files. So we can test it with video in the future, but just right now is do it with files and with the small files. But I think that it is because the limitation of the model, not because the platform. So we can test in the future other models and see how the portal will be with these files.
Did that answer your question, Lance? You can unmute if you want, if you have any follow-ups on that.
Thank you.
Right. Are there any other questions? Okay, while we have others maybe thinking of questions, I have a question, Diana. So, so I'm curious, what made you choose AWS? I know there's the whole Lambda and serverless compute, and you had mentioned being able to scale resources as you need, but do you have plans on using other cloud platforms or other resources in the future? What sort of pushed you to use AWS in this case, apart from the features that it provides?
Yeah, we use AWS Lambda because in the research group where I belong, we developed a tool called SCAR that allows us to create run applications packaged in Docker images on AWS Lambda. And in the future, we want to extend this tool to other platforms, so Google or Microsoft Azure. But just right now, this tool is for AWS Lambda, and for that we choose AWS.
Okay. I think we have time for one more question. Let me just check the Google Doc to see if there's any other. No. Okay, I have one last question. So how easy is it to add a new model to the platform if you had to maybe add a new say deep learning model or something else, or a new machine learning model? Is it designed to allow people to contribute their own models, or does there need to be some sort of administrative privileges that that are needed to do that.
Well, to integrate models.
Yeah, to add a new model to the platform.
Okay, just right now, the models that we integrated are from Deep Hybrid Data Cloud European project because they are integrated with DPaaS. That is one of the tools that are important in this platform. So I think that a user needs to integrate the model with DPaaS, and then this will be very easy because we develop a command line to obtain the prediction of the model through DPaaS. So I think that first we need to integrate it with DPaaS, and then everything will be easy.
Right. Well, thanks for answering those questions. I think we will have to move on to our next presentation now, but there's always time in the last 15 minutes if anyone has any more questions for Diana.
Okay.
I think